Okay, so in this video we are looking at changing numbers into scientific notation. So scientific notation, what it looks like is, I'll show you a few examples. So for example, this here is scientific notation. This is also scientific notation. And here is another example of scientific notation. So key features that we can see is this times 10 to the power of something. So that is always a feature of scientific notation. The other thing is that we only have one number that is in front of a decimal place. And here, there would be a decimal there if we needed it. And it's just a 4. So, for everything, whenever we are doing scientific notation, we must only have one number in front of the decimal place. So let's take a look at a few examples on what to do. So right now, we have this number here. We have 86,400. Our decimal place is at the back here. Our goal is to get it behind that 8. So to start off with, the setup of our answer is going to be 8.64. You don't need the zeros because they don't really add anything. And then we're going to have that times 10. And to identify what the power is going to be, we count to see how much that decimal place has had to move. So 1, 2, 3, 4. So that's going to be 4. So again, counting between each little dip. And the key thing here is that I am drawing in the dip. Okay? So that was 4 spaces I had to move. So 8.64 times 10 to the 4. So let's take a look at another example. So right now, our decimal point is here. We want it... Oh, actually, that's question 3. I'm over here now with question 2. So here I have 12,530,000. Our decimal point is here right now. We want it to be here. So our setup for the question is going to be 1.253 times 10. And then we need to count the decimal place. 1, 2, 3, 4, 5, 6, 7. So 1.253 times 10 to the 7. Next example, decimal point is here. We want the decimal point to be there. So I'm going to have 2.5 times 10, and it will just move once. So I can put a 1 there, but that doesn't actually make much of a difference, so I don't really need it. That doesn't have to be present. Okay, next one. Decimal point is back here. We want it behind our first number. So our setup is going to be 2.5. And unless it says otherwise, unless it says to give it to a certain number of significant figures, just sort of include it down to where your last non-zero number is. But it could say give your answer to 2 significant figures, and I'll do that now. And so to 2, it will just be 2.5, because that 0 is just going to round down everything else, so the 5 will stay the same. So 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Next one here, I've got 300,000. So I could put 3.0, but I don't need to. I can just have 3 on its own. 3 times 10 to the 1, 2, 3, 4, 5. And here I've got 2.83 million. So if I was to write that out, it'll be 2,830,000. And so it's going to be 2.83 times 10 to the 1, 2, 3, 4, 5, 6. Okay, so that's how to deal with large numbers. So large numbers, as you can see, our power is always positive with a large number. So a large number always a positive power. And a large number is strictly numbers that are bigger than 1. So if the number is bigger than 1, then it is always a positive power when we're doing our scientific notation. Okay, so let's take a look at some small numbers. So here's small. Now the general idea is the exact same. We want that decimal point to go behind that first non-zero number. So I'm going to have 4.6 times 10. Count how many spaces it moves. 1, 2, 3. But because it's a small number, it's going to be -3 for the power. Same over here. This is where I want my decimal point. So I'm going to have 8.005. And it's going to go 1, 2, 3, 4, 5. So it's going to be times 10 to the -5. Here I'm going to have 2.465. Decimal point's going to go to here. And it's going to move 1, 2. So it's going to be times 10 to the -2. And last one, our decimal point is here. We want it to move behind that 5. So it's just going to move that once. So I'm going to have 5 times 10 to the -1. So a small number, as we can see, always negative power. And a small number is going to be one that is in between 0 and 1. Okay, let me know if there are any issues and good luck with the work.